Greetings, welcome to another fun video from iCampSA. So today we'll be doing this question paper. This is May, June 2025 question paper, physical science. Okay, let's start. This is question 4. So we have trolley A of mass 1.5 kg at rest on a frictionless horizontal surface, right? 1.5 kg. Let's mark it using this. And then a second trolley B of mass 2 kg traveling horizontally at a constant speed v. So that means the speed is not known, it's v. So collides with trolley A, right? The trolleys stick together and move at a constant velocity to the right, covering a distance of 0.8 meters in 2 seconds. Okay, this is our data. This is very important for us. Okay, we're gonna be using this. So now let's start. So they're saying state the principle of conservation of linear momentum in weights, right? So as we know it, they may not write it in weights at first. So I'm gonna write it. This is the conservation of linear momentum, right? What does this mean then? This is telling me that the initial momentum, the total initial momentum, this is a summation. So every momentum before collision that we're going to add should be equals to every momentum after that collision. Okay, so in weights it means the total linear momentum in an isolated system remains constant. Okay, right, let's write it down. Okay, this is it. The total linear momentum in an isolated system remains constant or is conserved, right? So it does not change. Before collision and after collision, it should remain constant. Okay, so now let's see question 2. They're asking us to calculate speed v with which trolley B moves before collision. Okay, so now this first question tells us a formula that we're gonna use for us to answer the second question. So let's use this principle here, 4.2. We are going to use the principle of linear momentum, right? So we're gonna have pi, initial momentum, being equals to final momentum, like so, right? So now that means we're gonna have momentum. This is gonna be momentum 1. This is gonna be momentum of A plus momentum of B, being equals to, this is all initial, right? This is all initial. And then P A plus P B, this is final, right? So in simple way, we know that P is equals to mv. We know this, right? We know this. So that means we're going to have P, not P, we're going to have mv. This is all for A plus mv, all for B, which is initial, and then ma mv A plus mv B. This is all final, right? And then we can go back and calculate our initial. So here the speed that they are looking for is before collision. So that means it's this side, right? It's the initial one that we are looking for. So how do we then calculate this? We come here because we already have our data. Remember, let's start with trolley A. Trolley A has 1.5 kg, right, of mass, and it's moving at what speed, right? So then 2 kg is the one that has this unknown speed here, right? Okay, then let's move and see how it goes. So we have A, which is 1.5, right? Remember, A is at rest. This is a key point also, at rest. At rest, we are saying VA here initially is 0. Okay, and then this one is what we are looking for. So we're going to have 2 VB like so. right, initially. Then we can move, then we have MVA. But now what happens here, what we should note, these two trolleys are now one thing, right? This is now one thing. So that means we're going to have one velocity, right? We're not going to have VA and VB. So if we can update this, we're going to have something like this, right? So we're going to have MA, MB all times V, right? This is gonna be V, the final V of this system, right? That's why we are adding it like this. So that means we are going to have 2 kg and then plus 1.5 kg. Now this thing is moving at a same velocity. All right, now that means we've got the same velocity V here, right? But we don't know V. So now we should find out what is V. Okay, we should find out what is V. What have these people told us? They've told us that this system has moved 0.8 meters in what? In 2 seconds. Okay, 0.8 meters in 2 seconds. So now let's find out what is our velocity. Remember, what you must remember here is that velocity is equal to the change in displacement and change in time. Okay, this is what we have. So that means our velocity here, we can say 0.8 because this has moved this 0.8 distance all over 2 seconds, right? So that means we're going to have 0.4 meters per second as our velocity. Remember this here, right? So we have gotten this V. So now this V here is this. Okay, this has simplified things for us. So now we can go back. We've got this is going to be 0 here, this is going to be 0. So now this is going to be 2 VB being equals to 2 plus, or let me just say 3.5 times what? Times 0.4, right? If we divide by 2, right, we're going to have our VP. So let's punch in our calculators. And the answer is 0.7 meters per second, right? This is the magnitude, right? This is the speed V before collision. Okay, so now we've got an interesting question here. This one here. Now they're asking us, is this collision elastic or inelastic? Okay, that is the question. How do we then answer this? Remember the principle says for an elastic collision, let me put it on the other side. Okay, so for an elastic collision, which is 4.3, elastic, let me write it here, elastic, that means we're going to have, this is the sum of kinetic energy, initial kinetic energy, right, should be equals to the final kinetic energy. Okay, this is elastic. And then inelastic is not going to be equal. But what happens is, for both these cases, okay, for both these cases, the momentum remains conserved. Okay, here, this is how we're going to determine, but the momentum itself is going to be conserved. So what you can do here, if you just don't want to confuse yourself, because we've already gotten the velocities and everything, right? So what you can do is, let's take these formulas and check if both sides are equal, right? Let's take the sum of, this is the sum of the initial kinetic energy. So that means we're going to have 1 over 2. The mass, let's take off block A. Block A initially is at rest, plus 1 over 2 1.5 kg times the 0.7 that we got there. Okay, then you're gonna have an answer here. Okay, and I'm going to punch my calculator at the end. And then here again we have the sum of kinetic energy final. This is gonna be, now this is one thing, it's gonna be kinetic of this whole block. So that means we're going to have 1 over 2, it's gonna be 2 plus 1.5, like so. Okay, and then what happens then is that you have our V squared. What is our V? Actually, this is our V on the other side. Okay, 0.4 squared. Then we should have our kinetic energy final here. So let me punch our calculator and see if these are equal. Okay, this is what my calculator is giving me. For initial kinetic energy is 0.3675 joules. Okay, and then for the final one is 0.28. So that means an energy was lost here, and kinetic energy was lost. So we moved from this and then it decreased to this. So we've lost it. So this, then we conclude here and say that means initial is not equals to final. Okay, it's not equals to final. What does this mean? This means it's an inelastic collision. Okay, so this is your conclusion. Okay, so you can do this. Sometimes they're gonna ask you to prove using this, so you should know how to do this. Okay, so now let's move to a last question. So now they're asking us here, during another collision, trolley B exerts a greater force on trolley A, and the change in momentum of trolley A is the same as before. How is the time of the collision affected? Choose from increase, decreases, or remain the same. Write down the relevant equation that supports the answer. Okay, so here we are going to use 4.4. We are going to use impulse, because we are talking about force, we are talking about time, and we are talking about the change in momentum. Okay, you should listen carefully to the statement. What does the statement say, right? So here we've got delta T equals to delta P. We all know this, right? So now they're asking us what happens to the time, which is this change in T. So you can rearrange this and write it as F net being equals to the change in P over the change in time. All right, this is the rate of change of momentum. Okay, so this here tells us, let's write it like this: F net is directly proportional to P. So that means if you increase the change in P, change in momentum, you are increasing the change in, you're increasing the net force. But here they are telling us that the change in momentum remains the same. So that means these two don't affect each other. We are going to look at time. How does the time, how is the time for the collision affected, right? And then we've got this important point here. Let's do this important point like so, right? So now here we know that this is directly proportional. Let's write it directly proportional. Okay, that means if you increase your F net, or you increase your change in momentum, that means F net is going to increase. And then what happens then is, let's write the same equation. We've got the change in P over the change in time. So what this means is that F net is inversely proportional to P, to change in time. Okay, to change in time. What does this mean? This is inversely proportional. Okay, So what this means is that if you increase the time, you are decreasing this F net here, right? This is what is happening. If we increase this time, this is going to decrease. That's what we are actually looking for here. So then, if we then decide to decrease this, this is going to increase, okay? But now we are talking that we have this as increased. So that means this time will go down. It's going to decrease. So if you increase this side, that means we have smaller time, because time, if you increase this time here, this is going to decrease. But if you decrease this time, this is going to increase. And according to the statement, this has increased. So that means we have reduced time. So we can conclude and say the answer is decrease. Okay? This is the answer. So you should know these two principles. If they were talking about momentum, we were also going to make a different conclusion. Okay? That's it for our small question here. Hope you enjoyed it. Thanks.